Welcome to the 7th session of the R workshop. As you may recall, last time we were still walking through the example data set that I shared, and I wasn't quite done with that. So I'm going to finish that up before moving on to the plotting demonstration. As a reminder, this file here contains some example analysis that might be done on the expressive law study that I described the last couple of sessions. Anything in this file should be able to be run after the processing file that I already walked through, I think, a chunk of last session and starting 2 sessions ago. So in this R environment, I've just started R and run the processing syntax again so that the analysis syntax will work fine. You could, of course, always save the global environment as a file on your hard drive after running the processing syntax. You don't need to rerun it each time. I just didn't do that last time. So this that you see in the console right now is all of the result of running that file that started like this. Okay, so the next thing I was going to talk about some ways to take a look at information about variables split by condition, which is a common thing that people want to do in psychology. And the probably sort of classic way to do it, the most common recommendation from teachers and like is likely to be this tapply function. So I'll show you an example of that right here. I'm just going to run this. I think I had the data attached before, and I don't right now. So we were working with data.ok. So I'll just do that again. So as a quick reminder, when you load working environment that you've saved in R, it does not remember the search path. That is, it doesn't remember all of the packages and or data sets that you have attached. So that's something you would reattach the proper packages and data sets if you wanted to after loading a working environment. But in this case, I didn't even do that, right? I just reran the processing syntax. So of course, that wasn't attached. So this line of code just gives me the mean response to the discrimination is legal question in the illegal condition and in the legal condition, which suggests that the manipulation worked, or at least it worked well enough to lead to a wide discrepancy in responses about whether participants believe that discrimination currently is legal, which of course it should have, because we literally told them that the judge in the lawsuit said discrimination on the basis of mental illness history or depression is legal or illegal. The reason this worked to give me that information, tapply is a function that runs another function on subsets of an object, such as a data frame or a vector. And the first argument here is the vector I want to work with. Discrim is legal is a single column in my data set. And cond is another column in the data set that has a small number of unique values, in this case just 2, illegal and illegal. And so by supplying discrim is legal as the first argument and cond as the second argument, I'm telling tapply that I would like to partition the values of discrim is legal into sort of subsets representing all of the unique values of cond, so that I have all of the values of discrim is legal that are in the same serial positions as the illegal values of cond, and separately all of the values of discrim is legal that are in the same serial positions as the legal values of cond. And on each of those subsets of discrim is legal, I want to calculate the mean. Mean here is the name of the function in R that calculates the mean. I could use any function I wanted here. A function that I had written, for example, would be perfectly fine, or a more complex function built into R, but here I'm just using mean. And this is a common way of using tapply. And then the extra arguments after that, in this case there's just one, are extra arguments that R will that tapply will automatically feed into this function mean. So na.rm equals t. If supplied as an argument to mean, will tell R that I want to calculate the mean just of the values that don't have missing that are not missing. So we'll only use valid observations to calculate the mean instead of returning a missing value if any of the observations are missing. By supplying it here as an argument to tapply, and this is an argument to tapply, right? It's the fourth argument to tapply structurally is what's going on here. Tapply is built so that it takes all these extra arguments and just copies them directly into each time it calls the function mean. So that every time it asks for a mean, it will automatically ask for a mean with na.rm equals t. So as a result, I got the mean of discrim is legal in the illegal condition and in the legal condition. Hopefully that explanation makes sense. Please let me know if you have any questions. I might be interested in doing the same thing to learn about some of the more interesting variables. So this one is exactly the same, except it uses this other variable, most support discrim, which is the response to the question in which participants guessed whether most other people's support are in favor of discrimination on the basis of mental illness history. And we can see that there seems to be a slightly higher mean in the condition where they were told that such discrimination is legal rather than in the condition where they were told that such discrimination is illegal. Of course, I would want, this is not a statistical comparison, I would want to know the amount of variability in the sample size, among other things perhaps, just to demonstrate how this function can be used. And I might do the same thing for participants' own indication of how much they support discrimination, which appears to be higher in the legal condition. And their evaluation of Amy, the person who brought the lawsuit in the scenario they read about, and the evaluation of people with depression and other mental illnesses measure based on z-scores of the various items that went into that, or even how much they say they trust the courts, which of course I would not expect to be affected by the manipulation, but I would like to know if the average value was different in the different conditions, because that could be a problem for some of the ways I would like to use this variable. So that's the tapply function. And the apply functions in general, there's lots of functions that have the word apply in them. Tapply is just one of them. Apply itself is a useful function. Sapply is also useful. And this family of functions is very powerful, and I use them a lot, but they can become quite complicated, especially for beginner R users. Please feel free to ask me later for more information about these kinds of functions. But for now, I want to show you a few other ways of getting the same information about the mean of various variables in each of the two conditions. So here's one very simple way that if the tapply stuff seemed sort of confusing to you, you can always do this. It's a little more cumbersome, but it gets the job done. Here, I'm just calling the function mean directly, and I'm asking for the mean of discrim is legal, and I'm using the square brackets that we've already learned about to carry out subsetting. So here, this first argument to mean will be the vector of values in discrim is legal such that the cond variable is equal to the value legal. So this portion of the code, if I just run that, these numbers represent the values of discrim is legal in the rows of the data set that meet this condition, that cond is equal to legal. And the only other thing I'm doing in this call of mean is specifying that I want to remove missing values. So this line of code uses only stuff that we've covered in the introductory portion of the R workshop. Nothing fancy like tapply. And here we get 5.0, the mean in the legal condition. And we can do it again with illegal and get I just accidentally ran just that word. I wanted to run the whole line. 2.5, which was the mean in the illegal condition. So if I run the tapply version, again, we can see those numbers are the same because these strategies are doing the same thing. So if I was confused by tapply, I could run these two lines of code and I could get the same information. I also shared with you this file called extrafunctions.r, I'm pretty sure. That contains a bunch of utility functions that I've written over the years. Not all of the ones I've written over the years. If you have other things you'd like to do that might be convenient, let me know and I'll see if I have a function for it. But these are ones I decided to share for this workshop, and one of them is called DES. For descriptive statistics, in that way resembling SPSS syntax. And the des function just takes one argument representing the variable you want to describe and a couple of other arguments, in this case just one, representing how you want to split it up, how you want to subset it. So here, this function will just give me information about discrim is legal for each of the conditions. And there I can see the mean was 2.5 in the illegal condition and 5 in the legal condition. And I also get some other useful information. The standard deviation and median, the number of valid values in each of those conditions, the number of missing values. You can see there's one missing value in the illegal condition, so we would have gotten NA for mean if we didn't use NA.rm equals T earlier, and the empirical minimum and maximum. This function is similar to the describe function in the psych package, I think. Yeah, and that is in this, or is that in the base? I always forget that. Yeah, it's in the psych package. Good. So that time I remembered right. And I think that you can even, I hardly ever use that function, but nope. Okay, you can't do, it doesn't like take a second argument that splits it up. I'm sure there's a way to split it up, but I would just have to specify what argument it's using. So I wrote the DES function for myself because I find it convenient for the very next argument after the variable I'm describing to be the variable I'm splitting it up by, because that's my most common use case for this kind of thing. So there it is, and I can do that for all of these variables. And now see, for example, that the variability seems to be higher for I support descrim than most support descrim. These standard deviations are a little higher. I mean, some other things that I might be interested in learning about. But essentially the goal here is the same thing that I did with tapply above, but just a different way of doing it. And of course, I could run tapply again with SD instead of mean to get the standard deviations, and with other functions to get this other information. You can also look at subsets based on multiple variables at the same time using tapply. So here's an example of that. This is the same thing as before, tapply with the first argument being I support descrim. But now the second argument, instead of just being conned, I'm supplying a list that I'm constructing on the fly of conned and ever depression. This is the, as you may recall, the binary variable indicating whether the participant reported that they had ever experienced some kind of depression or not. And so here I'm telling tapply that I want to use both of these variables to split up the values of I support descrim. And then I'm going to run the mean function with the na.rm equals t argument. And here I get a matrix of the means of I support descrim under all four combinations of the unique values of conned and ever depression. And so this one is conned and this one is ever depression. So those values I just coded as no and yes. And that's one way of accomplishing that. Probably the conventional way of accomplishing that. You could also use a bunch of lines of code like this. If you were confused by tapply, you always have the option to just use regular old subsetting. So here I would have to call the mean function 4 times for all 4 combinations, but that's not so hard. This is one example of those 4 function calls, where the first argument is descrim is legal, and then square brackets subsetting it so that conned is legal And, this is the and symbol, and U over depression is no, with the na.rm equals t argument. And I get that mean for discrim is legal in that combination of conditions was 5.06. So I used discrim is legal there, but I guess for the sake of comparison, I should use I support discrim. So there, the mean in this combination of conditions is 3.75, which is the same as what we got in the legal no combination from tapply, as it should be. And I could also use my DES function for that because this is a thing I commonly want to do. So I wrote the function so that the third argument can be yet another sort of condition set of variable to use for subsetting the original variable that I'm describing. So here I just supply three arguments: the variable I want to describe, and the two variables that I want to partition it by. And if I run that, I get a table set up where I have the mean and standard deviation for each of the combinations. So this is the mean for the no value of U over depression and the standard deviation for the no value. And this is the mean and standard deviation for the yes value. So you can see that my DES function dispenses with the median, count, missing, min, and max information when I supply three arguments instead of two, because I wanted to display the information in this table, so it's a little neater just to have the mean and standard deviation, because I often find that convenient. But you could tweak the function to do whatever you wanted it to do, or even write your own built-on tapply. I think that my current version of DES doesn't even use tapply. It probably should for efficiency, but I seem to recall testing it a few times with and without and finding essentially no efficiency gains um, in this particular case from using tapply even on big data sets. Don't quote me on that because it's been a while.